think I actually know everybody in the audience, so I guess I could talk like I don't know you. So the ETC is a nonprofit think tank. We've been around about 32 years now. We were brought together by George Lucas, who said we want to work together as a community. So I report to the board. The board is the CTOs of Disney, Warner Brothers, Universal, Paramount, Sony, Epic Games, all the fun players. I think Google's also on there, and Microsoft, Simon over there. So we had a couple really cool people that are involved in it. So what do I do? What do we do? We look around the corner. What's coming up? What's critical? What's the future? And I give away a grant every year to begin to put things into action. So it's not simply about testing or knowledge and best practices. It's let's see how things actually work. Let's put it into real context of a production end to end. So what I'm going to talk to you about is Grant 8. Grant 8 is basically our latest grant. And what it is it's focused on AI and kind of a hybrid form of AI. I would have to say that Hollywood isn't really quite ready to go pure generative, especially around actors and people. So this one that we're shooting basically multicam iPhone of the characters and then changing or translating the backgrounds, right? Using AI and creating these backgrounds. So this one's about a young girl who basically finds this heirloom, which is a flute, and she breaks it, and it kind of transports her back to her family in prior generations so she could find out that cultural relevance in her life. And we've got a wonderful writer-director right now, Felipe Vargas. Felipe Vargas, if you don't know, is actually on the road proselytizing about his brand new full feature, which just came out. So he's got a horror film out there right now called Rosario. And he's also doing Bob the Builder with J-Lo. So he's the man on the move. This guy's like rocking it. So I kind of talked a little bit about this traditional hybrid film elements blending with AI tools. You know, we're always about empowering the artist along the path, and that's what's critical. A lot of people think that this is just going to switch from typing prompts in and getting a movie out, and nothing could be further from the truth. If you start looking at how actual pipelines work, it is still going to have these creative department heads. It's still going to be having all these other components that we're used to, but they're going to move at a much faster pace. Again, the video workflow, we were looking at beyond just that. We were also looking at things like 40GS or 40 Gaussian splats. How do we reorient the frame or the picture to redesign the shot? So let's look at some reference architecture here. So we have this wonderful gentleman by the name of Con Wilms who leads up hardware architecture for us. And this is really critical when you're doing workflows in AI. So everything what you see here is all Docker or container based, so that you're getting the flavors and packages of all the dependencies into a single Docker container. So we have pretty much 4 different types of compute, and I don't know that all 4 are represented here, but we're going to have a virtual machine that they're going to be logging into. That virtual machine is on Create. Create will then also go to either AWS Cloud for Pathways, which is this one. The other one is on VO2, so those resources will also go to VO2. We also have 2 boxes on set, 2 HP machines, which are dual A6000 boxes for hardware locally found. And then finally, it looks like we're going to be logging into a compute infrastructure called Massive Compute, to train some of our models, which will be on H100s, H200s. And we simply can't afford to put those on-prem. And even in Amazon, it's a bit expensive for us to run those long-term. So what you're seeing here is a private basic mesh network that brings everything together that you're logging in from all of this. So let's talk about this idea of creative intent mapping. So again, one of the key goals here is about getting copyright. If anybody is familiar, there's Slice of American Cheese was the first piece of AI created artwork that got a copyright. And what happened was when they submitted with their 300, 400 prompts, Copyright Office said, no, that's not acceptable. You have to show us how the human iterated with this within the goal and intent. So they had to go back and resubmit their paper for this image, showing how they manipulated the image afterwards, which is a very critical aspect. When you look at it in the long term, when you're looking at characters, full stories, a studio perspective, this is going to become a much larger problem than you might naturally have assumed. So what we have to do is we have to begin to, again, create a mapping of that intent, and look at the different aspects of what was the intent of the human or the artist across this thing. How was it guided by the artist? What came out of AI? What are the prompts? Other things? How do we then manipulate it from there and further from that? So here's another one of our fun little documents where it kind of breaks down the major silos of data and media, and so how we're beginning to look at where these pieces of information come from. Again, you've got data coming from so many different systems when you're building some of this stuff out. For example, when we worked on Chickaboom, we used some public models to define what the look of a person was, but then we air gapped that by hand drawing those models. So we had a pathway in this one. But again, you're going to see that there's quite a few different silos. And Dave's going to get into a little bit more about how they overlay from that. Are you the next slide up? Yes. So I want to introduce Dave King, Perpetual Intelligence.
Thanks so much, Eric. Great, thanks everybody. We thought we'd start with something that wasn't black and lots of complications, but we're actually going to go back to Eric's slides and show you how we can actually look at the provenance and the background of how the humans are interacting with AI models through a content production workflow. So a little bit about perpetual intelligence and using AI in any enterprise-oriented pursuit. There's a bunch of problems with AI. It's wonderful and it's powerful in certain respects, but it's dangerous when it comes to other elements of using it in an enterprise. These are some of the issues between ethical controls, data security, access to the model, which really has all of your crown jewels and IP inside of it. We've decided that with this problem here, there's a solution that needs to come together so that you can work in content production and work in general enterprise to make this safe. So we've built the Perpetual Intelligence platform. It's really got 3 engines that drive it, and this is something that's model agnostic and sits on top of any workflow. So we'll go back to Eric's workflows in a minute and show you how this maps on a real live content production and handles things like copyright. So at the bottom left, we've got the security engine. This sits like an umbrella on top of any models you're using in any content production or any workflow, and it provides inbound and outbound security. So you can't prompt engineer and break the model, and you can't hack it from the outside either. The audit logs that come out of the security engine create a streaming data stream that allows you to track all the human interaction and all the AI interaction and the data flow in between. I'm going to demo this live for you off the laptop as soon as we're done a couple of slides, so you can see it. And it's not easy to demo this because it's a streaming data set that happens over time. So now that we have insights coming out of the security model, we can put that inside the next interaction a human has with the model and provide the model with context. So everyone may have heard of a context window, which is the memory that a model specifically has. We've essentially replicated and built almost an infinite context window because our data stream remembers everything that happened. So if you show up and use a model 4 days later, it knows who you are and it knows what you did 4 days ago and can continue the conversation. And so our context engine allows the model to be aware of its surroundings. It understands the project, it understands you, and it can keep on going where you left off. Then we use all that data to learn and retrain and fine-tune. So inside an enterprise or a project, you don't want the model to just continue to react to the way it was originally trained. You want to tune it up and make it better over time, make it more personalized, make it more focused on what you're doing. So it's not just looking at other data coming into it and sort of adding it to the answer, it's actually getting retrained on the fly. So we're in the process of filing. We have filed for a bunch of patents on all of this because a few things we're building here are quite novel and unique. But they're designed to solve real problems. So back to Eric's slides, we've got some acronyms here to try to keep it there, but the color orange works quite nicely. So between our data pipelines, our learning engines, our security engines, and the context engine, they overlay against any time there's a model interacted with, either a human coming inbound or a response coming outbound, or data going in and out. We're trapping that, logging it, and giving it those things we just talked about. So across all of Eric's view of the tech pathways, the workflows, and the human interactions, we're integrated into all of that, but we don't change any of the tools that are used natively. We essentially sit on top like a proxy. We're a man in the middle that just supervises and analyzes what's going on. So in real time, we can actually track the interactions of the person, but we can actually track the behavior of the model as well. So if a model gets confused or answers that my favorite color is red on Tuesday, when on Monday it answered my favorite color was blue, we can actually track and alert that to make sure the models aren't drifting or getting dumber as they go along. Because large language models actually don't know what they're doing, right? They're simply guessing at what the next word or the next token should be. So we can track drift and behavior as well to make sure things stay on track as you use models over time. So in this case, as we look at provenance and tracking, where did the information come from? What did the human do to actually start to build a copyrightable output? We track all of that, and again, we just overlay. So there's nothing that you need to do that interrupts your business, your workflow, or anything else. So a little bit about our platform, and then we'll dive right into a live demo. And I'm a bit of a risk taker, so we will do it live off the laptop, and we'll see how well she goes. You never know. So we're designed to run on any cloud, on-prem, or a hybrid thereof. So we don't really care. We don't really care about the models either. It sits on top of any model, any family of models, and it'll work on edge devices as well as it works with AI agents. So it could be 5 models with 50 autonomous agents running in your workflow. We can supervise and track all of that to make sure we keep it safe and keep it aware of what it's doing. There's actually hundreds of events that happen. For the demo, I'm going to isolate it to 3 or 4, because hundreds, we would not have a crowd of even 10 here if we went through the hundreds. That's too boring. But we are designed to work across any model and any physical architecture. So here's what we're going to show you. So we're going to show you a model that, in fact, Eric and the team at ETC chose, the Qwen 2.5 model, 7 billion parameters. We're running it locally right here on this HP workstation. And we're going to run our security engine with a subset of filters. So I'll show you a plagiarism example so we can trap plagiarism. We can trap role-based access control. So I'm going to pick on Rick Hack from Perpetual today. He's not going to get the same access I get to the model as we go through a demo. And we even have a ratings filter built in. And then we'll show you actual examples of building a workflow and showing copyright provenance. So we can track exactly what the human put in and exactly what happened as we built it. Just for fun, I turned off the code generation and virus protection, so afterwards we can hack Qwen a little bit if you want to see it write some viruses. We can do that too. So we'll just click out of that. Here's the live. Oh, we got some screen. All right, so we're going to start here. There's actually 2 windows. I'm going to see if I can resize here. No, it's not letting me resize. There we go. This worked well before we put it on here. See if I can go these side by side. See, live demo. Simple Chrome window we're just running locally. So we've got some prompts built in here just to make it a little simpler for the demo. And we'll start with a couple here. We're going to start with a plagiarism filter. So the role of me up here, Dave King's the director of the film, and I'm going to ask the Qwen model to, in real time, drive a scene called Hero Baby that simulates the Lion King Simba scene. So we pop it up, and there's 2 things I'm going to show you here. The first is that it blocked it immediately. And so we've got resolution issues on the screen here. So it blocked it instantly through our filters. And so this request never actually made it to the model. So why that matters is because it didn't spend any compute resources. So I apologize in advance to Jensen and NVIDIA, but we didn't do an inference call to try to get an answer from the model that we knew would be blocked anyway, because it's inappropriate. It's tapping into content that the model should not be outputting. And if in fact that model had scraped the Lion King movie or had some of that content into its core training data, we're not going to allow it to come out because it's inappropriate for working on content production. So we ended up with our logs on the side here. Again, you can see it's live. So it went through the director permissions just fine because I'm a director of this film, but the plagiarism filter blocked it. So this is an example of, there's 340 elements that it actually looks at here. We're not going to show this on the demo, but as far as a streaming data set, this is a sample of what you're getting. So the user came in, it did something, it was clearly plagiarism to try to build something off of the Lion King movie, and so we killed it before it even went to the compute stack. So this cost us almost nothing to block this, instead of doing an answer, reading the answer, and then saying, well, this was inappropriate, why did I answer that? So we've stripped it up top, and again, this could work across 50 models at the same time, and it would still block it from hitting the compute stack. So very efficient and cost savings. In another demo that I can do live, we actually trick models into writing code and breaking their own guardrails. And our solution uses exactly 3% of the compute power of the ones where we actually jailbreak models. So we don't have time to go through that today, but it gives you an idea of what we can do. We can also block things based on PG, for example. So this one says, let's talk about some physical violence and see if we can extend across it. So in this case, we blocked that one as well. And if you go into the details, that one got through on the plagiarism and everything else, but our PG filter blocked it. So short little demos that gives you an idea of the type of thing that happens. Again, it didn't hit the compute stack to do that. All handled. And the way you build these filters is their natural language. So you can actually just type in as a user and say, this is the type of thing I want you to block. And our semantic engine makes sure it traps those in the requests and kills it up front if it's an inappropriate request. There's two levels of filters here. There's semantic engines and text-based pre-filters that screen out the bad stuff that you don't want to be answered. This is all in your control. And there's also a tuned large language model in the back that goes even further. So we can trap a bunch of other topics. So I think now it's time to, we're going to generate something that now I'm going to block for Rick here. So Rick is going to show up. He's our finance director. We made him the accountant on the film. And so we're going to ask it to tell us about the story that's about to be released. So we have a breach here because the story, the movie has not been released yet. We have someone in the finance department looking to get information on an unreleased project. So we click into that. That one gets blocked immediately. And we'll just go back to the top of the stream here. And this one was blocked because it's private information. Another reason. Now, if I run this query again as me, since I am the director, I'm allowed to do it. It'll actually go through, and we'll give it a minute. This is why we have a large HP workstation. This is actually building the response out of the Quen model on the fly. So you have one of these things that allows you to actually watch it in real time on how hard this hits the GPUs and everything else out of a workstation. So here's the Quen model. Went ahead and built the plot summary. Gave me everything that I asked for. It's actually quite long, so it did a nice story about the different phases of the movie. And if I go back, you can see this one isn't red. It went through and allowed it because it passed the ability of my access control rights to go ahead and let me do that. So as you can tell, these are a little hard to demo live and to do something in real time. I thought this is better than just canned videos and stuff like that. So last but not least, when we talk about copyright now, here's how we can show the provenance of what goes on. So I'm asking it to write a script about hobbits and to give me some names. So I want some different names. And so it went ahead and did that. So that's great. But in fact, those names don't look crazy enough for hobbits. So the human's going to go back and say, the hobbit names you just gave me weren't unique enough. Give me something a little more interesting. So go back, and can you provide me some better and more exotic ones? So pretty specific prompt. So it's going to go back. This is a simpler request, so it happens faster. So here's a few different ones that it actually went back with. And I'll show you these two logs. So the first one shows the time and date, all the filters that it went through, and the fact that it allowed it to go through. The second one on top of it, if you imagine this as a streaming data set, went through and said, Dave, the director, came back a couple of minutes later and actually asked the model to do something different with this new specific prompt. So as far as generating what you need from a copyright and provenance perspective, this allows you to build that. So over time, to build content of different types, you might have hundreds of prompts and refinements and everything else. You'll build up a data log here. Our system is designed to output industry standard files, so you can actually stream this into something like Prometheus and watch it happen and sort it in real time, or you can write it to blockchain. So you can have an immutable log of this that says, this proves, and it's never been touched since it was logged, exactly who did what and when. So if you had a massive team working on this and using AI for support, you've got the ability to take this into court and say, this is copyrightable because this date, this time, this human put in this prompt, and here's the full text of the response that came out of the AI model. And it also, like I said, we have 340 filters. I'm showing you 4 here, but it'll show that in fact it was screened, it was checked for plagiarism, it was checked for earlier copyrights, and you make sure that the provenance and any other breaches are all tracked. So that's the extent of the demo that I wanted to go through today without taking you down 900 rabbit holes. But you get the idea that now you've got an immutable log of all these things we just did. We trapped plagiarism. We kept the ratings controls in place. We trapped Rick from going in and trying to get into the movie before he was allowed to see that content. And then we allowed an immutable log to be created of what the humans actually did in real time. And again, remember that this now applies across all models at all times in everything you're doing. So if you also have AI agents in your workflow, moving something from this point to the next point, we'll trap the very same information. AI agent number 10 did this because it had this information and it output that and took this action. So all of that becomes part of this log, and we can screen it, filter it, and say, actually, wait a minute, even as an autonomous agent, you can't actually output that and take that action in the next step. So we can oversee it and block it to make sure that legal is happy with what you're doing. And in fact, you're doing everything you should be from a copyright and provenance perspective. So sort of in summary, we really look at this as the platform. So the platform allows you to secure the model from prompt engineering attacks. It won't spit out a virus for you. It won't spit out personally identifiable information, and it won't give up the movie secrets of what's coming out in the summer if you're not allowed to see that information. So teams can use this even if they have different role-based access rights. So we share memory as well, so we remember exactly what's happened, exactly what hasn't happened. So next time you show up in a session, you're right back where you started. If you also imagine the use of this in things that are human and interactive, so imagine you were running this locally on a cruise ship and using large language models for guest service. You'll actually know, because you probably facially recognized someone coming onto the cruise ship, you'll be able to know exactly what they like and how they've interacted with the system, and you can run new guest experiences in real time and have large language models interact with people because it remembers everything they've done. Not only with you, but anything else you might have in your data set. So we orchestrate all of that, and then we teach the models to grow and learn like humans. So they get smarter over time instead of dumber, and that is in fact a problem of drift and behavioral problems with models as you use them over time. So we deliver model independence, personalization, and we stabilize the outcomes of AI and allow you to do things like copyrightability. You can also audit models for their safety, because we can hit them up front with our security engine and say, there's a new one that came out, which of course there always is, which is why we went model independent, and that new model can be tested instantly against the system to determine if it's safe to use internally, or if there's some tweaks or guardrails you need to put around it. So it gives us all these different pieces to protect your IP, protect your research, and protect your copyrightability.